dive into some details, I want to answer like why Salesforce, a B2B company, so our customer is industry, want to play a role in this conversational AI or in general, like AI for understanding conversation, because we try to provide we focus on AI for CRM, which is abbreviation for customer relational management. So we want to provide all the conversation related understanding, including building chatbot, the platform, to the analysis of conversation. So our goal is not like our company, we try to build an end system for end user, but we try to build a platform that is easy to use and transparent for other industry, other business, other companies. Okay, so right now we're going to more like the overall map about what I'm going to focus on today. So here, as we all know, like conversation, there are two big sections. One is task-oriented dialogue, which I call TOD. This is our help to design user achieve specific goals, such as restaurant booking or hotel reservation. And this part, aiming to fulfill user requests within this number of turns, so be more efficient as much as possible. Another big category will be chit chat. There's no specific goal usually. Focus on making the response more engaging, more natural. And usually people focus on involve, common sense knowledge, open domain knowledge, like try to make the response more consistent and, like factual correct. And in this case, the more terms, the better. And for task-oriented dialogue system like TOD, like people focus on all these subtasks. For example, NLU, intent, domain, or dialogue state tracking system belief, or dialogue management about policy and interacting with knowledge base, or now NLG, like given the states and actions, we predict natural response. There's also, besides modularized, there's also end-to-end TOD system, which can categorize into retrieval system or generation systems. And there's all knowledge-grounded TOD systems. Here, there's two categories. One is conversational QA, which is such as dataset called QA or Quark, or there's conversational machine reading, such as dataset like Shark. For chit chat, like the most popular one will be personalized chit chat system, such as personal chat or give chatbot a personality. Or some people focus on, personalized for end user. For example, today, Jason, I want to personalize a chatbot for you. Then I need to gradually understanding what you like, who you are, where you're from. And in the end, I can personalize for you, right? And another big part will be knowledge grounded chit chat system, which separated into two categories: unstructured knowledge such as Wikipedia or conversations, or structured knowledge such as SQL or table informations. A big category of chit chat also includes empathetic chit chat system, which focus on understanding emotion or sentiment and adapt to the user. For example, if I know you are angry, like what should I react? Or I know you are happy, then what should I say? So this empathetic conversational system will focus more on this second level of reasoning behind the text service. Okay, of course, there are many other joint big area that people focus on in conversation, such as pre-training, for example, dialogue GPT or TopBERT, controllability, evaluation of dialogue, or cross-lingual, multilingual dialogue, or entailment dialogue, or continuous learning of dialogue. There's so many sub-area. But what we are focusing on today is something else like this. So I think you see a missing part here below TOD and CC. So here I want to introduce this third type of conversation, which I call info chat. So this info chat, such as email threads, for example, those Gmail communications, or panel discussions, such as the Zoom meeting we're using right now, or the work channel, such as Slack or Microsoft Teams, these working related conversational channels. So with all these different conversation, can we treat this conversation as external knowledge that we can do something? And what can we do on top of this? So today's talk, I want to focus on this blue part, especially the bolded part, like QA, extracted QA, or summarization, abstracted summary, which treat this conversation, structure, unstructured as input, and we do some downstream task. So here you can see there's some other example. I won't go through this. For example, there's informative extractions like FAQ construction or attribute extraction, or there is some conversational analysis such as discourse graph mining. Okay, so today the first part of the talk I will want to cover this paper, QA-Conf, question answering on informative conversation. This work was joint work between Salesforce.ai and HKUST. Quick motivation of conversationalized knowledge for this question answering. So the average official worker receive about over 100 emails per day in the US and uncountable message on different kind of platforms. And with the increase of remote working, we all know that working related conversation rely heavily on online communication tools. So in the right-hand side, you can see the example of the data set. So let's say we have some, email or whatever conversation back and forth between multiple peoples. And if we want to answer some question, for example, why IETF meeting create logistics and planning problem? If you ask this question to this conversation, then we will expect the model to reply, okay, because meeting tend to become too large. So we want to, so we create some issues, right? Or could have some other kind of entity related, like which city this meeting take place, or rondo, something like this. So in this paper, we want to answer is, can we learn or extract something from past conversations, or focus on this? Like we want to focus on informative conversations such as email, panels, and channels. So about related work, many QA data set out there, but most of them are focused on book, exam, or Wikipedia data. There are different kind of question answering setting, like home site, read comprehension, span-based, or open domain QA, but most of them are focused on this kind of data. And if people think about conversational plus QA, people are first think conversational QA, right? Like CoQA or Quark, but they're actually not what we want to do, something what we want to do, right? They are actually continuous QA pairs on a short paragraph. For example, if you look the example on the right-hand side, you will have basically some short paragraph either from Wikipedia, and there is some QA pair to QA pairs with some co-reference issues, and they try to answer based on this. So this is so-called conversational QA. But what we want to do here is QA on conversational data. So there are three related work. One is Mo Wen Ni, one is Dream, one is Friends QA. So in this table on the bottom, you can see what's the difference between a data set with. Is there any questions?
No, it's just a noise. Yeah.
Okay. Yeah. Okay. I'll keep going. So you can see the difference between our QA-Conf data set and other three data set. First, the source, like we are come from email, panel, and channel, and our domain is general. And from Mo Wen Ni or other domain, they either come from chit chat, like TV show, or they come from Ubuntu chat, basically a tech domain like was focused. And the formulation, our problem, our data set is formulated as a multi-span QA problem or unanswerable problem. So we have some question that was unanswerable for in the data set. And in terms of a question scale size and dialogue size, we have slightly higher, 2 times, 3 times higher than the previous work. And the big difference here is this average or maximum words or average maximum speakers in our data set. So as you can see here, the maximum number of words in our dialogue could be around 20K words, and maximum speaker can have 32 different speakers. Right? This is way larger than the related work. So this kind of data is coming from the Supreme Court data set that was, there's some high lawyer adjusting back and forth to discuss about something. Okay, so I want to talk about dataset collection, and this should be the most interesting part about this work. So our dataset are coming from 3 domains. One is email, we come from 2 dataset, panel discussion, we come from 2 dataset as well, and channels, we come from Slack. And there's 4 stages of when we collect the data. One, the first step, because our conversation is quite long. So first thing we need to do is do segmenting or disentanglement conversations. And then we need to generate, we propose to generate multi-hop question candidates before we send out AMT, Amazon Mechanical Turk, to collect some data. And then once we have this machine generate candidates, we crowdsourcing QA pairs. And then in last step, we do some quality verification and data splits. So here I want to focus on 2 parts. One is how do we get machine generate questions? The second part is how do we validate the questions, QA pairs. So we have 2 hypotheses. One is if we want to have some difficult questions, then this is something we got. Like one is we want to train a question generator that can be able to ask multi-hop questions. So the most naive way will be, okay, let's train the multi-hop question generator on multi-hop QA datasets, right? So we use HubSpot QA dataset to train this QG model. And second hypothesis is, okay, what if we use a dialog summarizer? Let's get some summary first. And then we ask question on this summary, and we can expect, okay, this question should be something that's important and not that trivial, could be potentially multi-hop, right? So based on these 2 hypotheses, given me one conversation or conversational chunk, I can have a lot of potential questions, right? But how can we tell which one is more difficult? So we can rely on a QA model, right? If our QG model, so QG model, it will also predict some potential answers, right? If this potential answer we use to generate questions and the answer we got from a QA model is the same or similar, then we think, okay, this is an easy problem that machine can solve. So we only filter and let human to annotate those hard questions which machine cannot do it right. The same when in the end we try to verify, okay, whether the answer we collect from human is correct or not. We do the same step, right? If a human written answer is different from machine predict answer, then they have some potential it could be wrong. So we need to do further verification about this, right? So in the end, for each conversational chunk, we collect 1 human written questions, QA pairs, and 1 question generation QA pairs. So the MTurker will be recommended with 4 QG question generation questions, and they can pick up 1, and we allow them to modify, but not just we recommend them not to modify too much, but in the end we cannot control, right? And here I want to share a fun fact when we do the data collection. So originally we are thinking, okay, one setting is I give you a conversation. I want you to write Q and A, right? So you need to do more job, right? Write Q and write A. And another setting is, okay, I give you conversation. I provide you some candidate of Q. So basically you just pick up 1 and then you write the A. Okay, so before doing experiment, I'm thinking, of course, people were, try to do the second one because it's easier, right? They can do this faster, right? So, but in the end, what we found is opposite, because writing your Q&A is like designing your exam and testing yourself, right? So it's very easy for you to, okay, let's just solve this simple problem. Who say this? Jason, right? So basically, it's a very easy question plus a very easy answer. But if someone can select something from our recommendation, then they need to do some additional work to find what we want actually. So it's just a fun fact, like, yeah, in the end, we need to pay more for the second options instead of the first option. And the last thing to point out here is we include 5% of unanswerable questions, and we force the Turker to have some at least 3 words overlapping between the questions and a source article, right? Because we don't want to have random and easy questions like, okay, why do you say that? And there's just obvious question, right? So we want to have something that was relevant and unanswerable. Okay, so this slides, I'm going to share a human evaluation about the quality between human right questions and question generation questions. So we do some human evaluation about this too. So first of all, if you look at this table, there's around 41% of the questions are from question generator. And out of this 41%, there's 33.5% of questions are with zero modification from human, which means they just click one of the four and then answers. And there's 20% they do a lot of edit. So we only compare this 33.5%, which 100% like human didn't make any additions, and compared to human written questions on the same conversation. So right now the comparison below is same conversation. One question is from human written questions. One question is from machines. And we evaluate this 4 dimension. Okay, first, average score. We found, okay, question generator QG questions are longer compared to human right questions. In terms of fluency, question generation is the win. In terms of complexity, what is complexity? Like how hard to find a question? Like how many numbers of sentence you need to look through in order to answer, right? So we found, okay, people found question generated questions are harder to find the answers. Like it's more complex. You need to go back and forth multiple times in order to find the answers. And a confidence score is, okay, you write an answer. How confident, are you confident 0 or 1, like your answer is the right answer? So we found, okay, QG model, QG questions, people are less confident like they are making the right answer. So which means this question could be harder or more, could be at the same time more ambiguous as well. All right, so let's look at some analysis about what kind of QA pair we have. So we show stuff like the question type distribution. For example, the top one of our question is what question. The second is which questions, how question, who question, when questions. And here is the comparison between other popular benchmark that we are using. As you can see, we have because we kind of try to balance this during data collection. So our question distribution are kind of more uniform compared to our existing data set. And in terms of the answer type, we found like, okay, 30% of the answer are noun phrase. This was expected, right? Because noun phrase are very easy to be answers. And we found, okay, because we don't constrain, the answer should only be entity. So there is some other interested, for example, there is some cause, like 5% of our answer could be a cause and effect. For example, why do you do this? Because you need to use an external store for states. This could be one potential answers in our example. All right, so now I'm going to just jump to the result part and talk about the observation. First of all, this is chunk mode. Oh, I forgot to talk about what is chunk mode, what is full mode. So chunk mode is, let's say we have a long conversation with 100 terms. So we first, I say we're going to do some segmentation. So we will get a lot of small pieces of chunk. So chunk mode evaluation is, we give you this chunk and you do this QA. So we assume that you already know this chunk, it's grounded, right? For full mode is opposite. Like we don't assume like you have this chunk. So first step, you need to, given these questions, you need to retrieve the most relevant chunk, similar to open domain QA, right? You need to have the retriever, whatever method you use to retrieve the top 1 or top 3 relevant information, and then you do QA. So here, this result is chunk mode. So in this column, as you can see, zero-shot performance. Oh, first, let me introduce what is EM, F1, and FZR. So EM is exact match score. So it means like after normalization, the answer is the same. And F1 score is token level F1 score. And FZR is fuzzy ratio score. So fuzzy ratio score is just the fuzzy library, which they calculate the distance, moving distance between two strings. So as you can see, zero shot performance, humans are way higher than the existing SailVR model. So there's two categories, right? One is span-based model, the SailVR model pre-trained, like Roberta model pre-trained on Squad 2, or there's no T5-based model pre-trained on Unified QA. So Unified QA is a QA model that pre-trained on 20 different QA tasks. And as you can see here, seems like freeform T5 model trained on Unified QA have better zero-shot ability comparing to span-based. This can have multiple reasons, right? One is like, okay, this T5 are pre-trained on more data set than this Roberta model. And second one is because our task is a multi-span problem, right? So our answer are not necessarily come from one single span. It can come from multiple span. So for this traditional span-based approach, they may, missing a lot of answer to be correct because of this start and endpoint prediction. It's not, comprehensive. And let's look at the zero shot column first. So as you can see, why T5 11 billion work comparing to 3 billion is a much worse. So this reason is just original T5 11 billion model released from this this authors. I think they are not well trained. Like they kind of maybe they release they did because the model is too large to fully train. So I think they have some issue about this model checkpoints. So we just ignore this checkpoint for now and we contact the authors. And we play with GPT-3. So basically we try to see some, okay, let's give some few shots, like some prompt to GPT-3 and see what it can perform. So we get some prompt from QA dataset, and then we do zero shot here in our domain. And it can achieve 53.7 exact match accuracy, which is quite high. Even maybe if we kind of playing with this different prompt, you can get even higher performance in this exact match score. And on the right-hand side is the fine-tuning results after fine-tuning our new collective trained data set. So as you can see, all the model can have, more like 10 to 20% of exact match improvement after fine-tuning on our data set. So this suggests that, okay, our data set distribution are really different from what standard QA trained on Wikipedia. So basically they can get a lot of improvement after fine-tuning on our data set, right? And the maximum EM score, which is 75.2 and 84.1. And as you can see, this number is already, quite close to human performance, like 4 or 5% different. But if you take into account this model are already beat human performance in Squad 2 or other data set, then you can see here, okay, we still have some gap to go. Here, I just want to show, okay, let's separate this answerable question and unanswerable question and see what can we observe. What we see here is, okay, for freeform model, this T5A model, they are unable to answer unanswerable questions. But on the other hand, for span-based model trained on Squad 2, they kind of over-predict the samples to be unanswerable. So as you can see here, they have very, very high recall, but very low F1 score. Means what? Means they are not understanding what the conversational is, and they just predict the answer to be unanswerable, right? That's why here the number is quite high, but the overall exam match score is very low for exam match EM score comparing to freeform models. So this also suggests there's some limitation about dialogue understanding in the current language model and also for QA tag specifically. So about full mode, here I just want to show, okay, let's use some retrieve some most relevant conversation, and let's run the same evaluations. What can we see? So as you can see here, every model, let's look at T53BDM model, have a huge like 20% performance drop once you do this full mode. And this full mode are more practical, right? Because in a real use case, you won't know which chunk, computational chunk should be the right to be grounded, right? So here, I mean, just there's a gap between here, like how can we improve this retrieval accuracy, recall, and also at the same time, improve the QA to bridge this gap. I think will be last slide of this session, which is error analysis. So we look at 100 QA pairs that have this error, have this FOSSEE score lower than 50%. So basically, very different. And we found that, okay, 20% out of these 100, actually they are making something reasonable. but for this current evaluation metrics, we cannot tell this. For example, UCLA versus University of California, or J Sonnenberg versus J, right? Both of this should be correct answer, but when you look at the existing metrics, automatic metrics, they are not exact match. They have low FOSSEE score or F1 score, but they are actually acceptable answers, right? And 31% of this answer are correct entity type, but but are wrong, but with correct entity type. For example, they both predict country, or both predict name of a person, but just predict it wrong. And 38% are wrong, wrong answer with wrong entity types, just totally wrong. And 11% of remaining are mistaken to are predict as an unanswerable question by mistake. So basically, they are answerable, but the model predict it as unanswerable. Okay, so before I jump to the next session, any questions? And here is just paper, code data, blog, and also our model is upload on Hugging Face. So if you are familiar with Hugging Face, you can just from pre-train, load our model and play with this. So very easy to use. Feel free to play around, and then let me know if you have any questions. And I will wait for like 5 seconds to take any questions here.
Hi, Jason.
Hey.
Thanks for the talk. I was curious at the beginning about one thing. How do you come up with the chunks? Is there a strategic way to decide those, or?
Okay, so for this work, the chunk was just collected by a buffer level. So we have a buffer, and then we accumulate once the number of turn achieve this maximum buffer, we just put it as chunk. But this is just one step. We also do for some data set, for example, Slack, we also do some dialog disentanglement. So basically, you can imagine that Slack is you have very, very long conversation. You don't know which is talking about what, right? So you need to kind of segment it by topic. So we use a pre-trained topic segmenter to segment like long Slack into different small conversational pieces. And then we use this buffer setting to either combine or separate between these different part.
Okay, I see. Yeah. Oh, thank you.
Yeah. All right, let me check my time. Okay, I have enough time to go through the second part. So the second part, I'm going to talk about abstractive dialogue summarization with sketch supervision. It's the same, like I want to do, which is give me a whatever conversation and let me produce something like useful information out from this, unstructured and noisy data. So this work is joint work between us and UCL. So here, just a quick motivation about what's the challenge here for dialogue summarization comparing to standard text summarization. So maybe you can quickly read through this dialogue. Like, okay, hi, what's up? Nothing special, boring days. Are you working at all? Trying to helping me, but just take a break. I miss you. Do you feel like going to a concert? Oh, that's wonderful. Thank you. I just want to be happy. So it's a, basically a chit chat between two people, right? So the challenge here would be in normal like Wikipedia or news text summarization. It's relatively easy because, you can always find like 2-3 sentences that are the topic sentence. For example, people already find like in news dialogue, news data, maybe top 3 sentences are always just cover everything, right? But here, as you can see, the information are scattered. Like people start from greeting, right? If you say, "Hey, Susan, what's up?" This is like meaningless, right? So the non-context noise and defluency is one of the unique challenge here. And also the information is distributed into different terms. So you cannot say, okay, this term is most important than this term, because usually you need to combine all of this and then you say, okay, they are talking about this topic and these are important, right? And of course, for dialogue, they always have this co-reference issue. You need to know who is talking about what, right? So I'm inviting you, and who is you? And so this is kind of a unique challenge when we do summarization in dialogue domain. So you can look at this human written summary from a data set. Okay, so you say Suzanne is at work and is having a break now. Morgan invites Suzanne to a concert of Maroon 5, which takes place next week at the Hulu Theater, and Suzanne agrees. Okay, so this is just a plain summary of all these conversations. So what we try to do in the first step is let's do some like summary sketch, right? Instead of one step, we want to generate final like natural summary. Let's do something in between, right? Let's find what is important in the conversations as a middle stage, and then we condition on this, we generate final summary. So what we are doing here is first we try to give some pseudo label for the intent. So here we just define 6 different intent, like why, you're asking about why, what, where, when, confirm, or abstain. So these 6 categories, we use a pre-trained model to just give a pseudo label of each term. And for key phrase selections, here is just quite simple. Like because we have summary label, and we just first, given this dialogue, I pass through this to a constituency parser. So I give some sub note, and I find the longest common sequence between the sub notes and the summary. So I know which sub notes could be relatively more important than the other. Wait 1 sec. Some people is texting me. Okay, so after this, so how can we represent a sketch? So we just first give this utterance index and the pseudo intent label and the key phrases which we found this mapping from the dialogue. So what we will have is, oh sorry, this jump to controllability. But here, what we will let our model do is just given all this input, I will first let our model generate which intent and if there's any key phrases within this dialogue. So I just do it in an auto-regressive way. I give them this encoder. I first generate token by token about this sketch, content is intent and key phrases. And then I will have a specific token, which is TLDR. Then I generate the final summary I want to see. So this is just a weekly supervision that we cannot make sure this is helpful, but just is something we try to incorporate in the supervisions. And in terms of controllability, what we want to achieve is, give me a dialogue. I can give you a 1-sentence summary, 2-sentence summary, 3-sentence summary, right? All of them should be a good summary, right? So here I want to control the number of output summary by partially highlighted input. For example, in the dialogue we just showed, here you can see we can somehow find a mapping between the summary sentence and the original article. Original conversations, right? For example, the first sentence like, okay, Suzanne is at work and is having a breakdown. Okay, this is basically mapping to the first 4 terms. right? And then we can by somehow find this mapping, and then we can, okay, then in this case, we can change our controllability into, okay, how can we segment this dialogue and control to generate one sentence summary at one time. And then in the end, we can control how many sentences we want as a summary. Right. So more detail. Look, first thing we need to do is just find a mapping between each summary sentence and the corresponding dialogue span. So let's say we have a summary, have 2 sentences. Then what I need is just find these 2 sentences corresponding to which part of the conversations, right? Here I just use Ruth1 to find this mapping. And then afterwards, what I need to do is I need to have a segmenter. I use BERT that can predict, okay, whether I should cut this dialogue, right, to A part and B part. So I can have each sentence over here. I can have a SEP, for example, SEP token between each sentence and have a prediction to predict whether this should be, binary cross entropy loss as a multi-label classification problem. I can predict whether this part should be a segment point, right? And once I determine how should I segment, I can either do these things. I can conditional on this whole things and generate one summary. Or I can, based on my segment model prediction, let's say this 0.9 over here, I segment the dialogue at this way, and I get 2 sentence summary, right? So I can basically, based on this segment distribution, to determine, okay, how should I highlight it, the input, in order to generate the output. So I'll skip the training detail here. Basically, here I just use this argmax with a similarity function to find this mapping. So this mapping, could be noisy as well. But here, this cross entropy loss is trained on this noisy annotation data, but it's still fine. And during inference time, I just condition on all this. All right. So our experimental result is run on Samson dataset, which is the largest dialogue summarization corpus. I'm not sure right now it's still the largest. I think so. With some automatic evaluation metrics. So as you can see here, there's some baseline. So the baseline on left-hand side of this green line, which is without any pre-training. Basically, they are either fine-tuning train from scratch using transformer model or some graph model without any pre-training embeddings. And in between this green and the red bar, red line, these are the baseline model we are looking at. So basically, we try DialogGPT, UniLM, Pegasus, or BART model trained on for summarization corpus already. Right, and then on the right-hand side, this 3 stuff like BART extend, sketch, BART plus control, or COTS is our model. As you can see here, in terms of this RUF-L, like the longest part of matching of RUF score, our model can have around 1.5 RUF improvement compared to the baseline. So although this 1.5 is not that high, right, just 1.5, but in terms of the RUF evaluation, I think 1.5 is already something that people think is significant improvement. And other than this RUF-L, we play with other automatic or like more advanced evaluation metric. For example, BERT score, mover score, or Cinder score. And we found, okay, the observation is consistent, like our model is better than Pegasus or BART XSUM model. So BART XSUM model is a BART model trained on XSUM. XSUM is a new summarization data set. And of course, for this summarization evaluation, we need to look at what humans think about the summary, right? So here, there's 6 different bars. So let's look at this 3, which is boxes by this black box. So these 3 are BART XSUM, our model, and the gold summary. As you can see, in terms of the length ratio, our model are lowest, are more condensed with higher compression rate. And in terms of consistent, what is consistent? What is informative? So consistent is you can think as a precision measure of factual. So we ask the Turker whether the information in the summary is correct, is factual correct, or is something that in the original document is covered. So this is a precision matrix. And informative you can think as a recall matrix, right? Whether the important information in the original dialogue is covered by the summary. Right? So here, the consistent matrix, as you can see, our model just work between the BART and Gold summary, and just mean like, okay, our summary are more consistent and more informative comparing to the existing pre-trained language model trained on Snow's corpus. And if you look at the left 3 bars, which is blue, red, and orange, yellow one, which is the longest one, BART 1, or COTS 1. What's that mean? So it means like we constrain the summary can only be 1 sentence, right? So here you can see, okay, in terms of the length, the longest one is the highest, and the BART 1 perform better. And here consistency seems like, okay, longest one are more consistent. Why? Because longest one is the longest sentence from the original article, so it should always be factual correct, right? Comparing to the original article. And here, in terms of this, our model and BART model are working the same. But if you look at its informative measure about this 1 sentence summary, our model have a big, huge win comparing to BART exam, which means if you constrain the model to only generate 1 sentence, our model can have more important information within this 1 sentence. And this is big win comparing to this longest and the BART model. Okay, so now it's time to play some guessing game. So I'm going to give you this dialogue context and then ABC, 3 different summary. I want you to guess which one is Gold summary written by human, which one is a summary written by our model, and which one is by the baseline BART model. Okay, I will stop here for 30 seconds for everyone to read and have your answer in mind. Okay, time to reveal the answers. So, okay, I would like to have some voting function here, but yeah, we don't have this function on this Zoom meeting. But yeah, the answer is, okay, the last one is from Gold, human written response, and the first one is ours. And the second one is from BART model, right? For me, all these 3 work perfect. Like if you tell me these 3 as a summary, I can say, oh, basically they are good summary, right? Maybe they have different compression ratio, but they cover the main point. Okay, someone sent money to a wrong account, and maybe you don't need to mention what is the account number, but this guy will go to the bank tomorrow to resend the money, right? So depends on the granularity, but all 3 of this catch the kind of key information they want to in these conversations. Okay, and here I just show the generation result from BART 1 and COTS 1. So basically, how can you use 1 sentence to cover this conversation, right? As you can see here, our model kind of have a huge win compared to this baseline BART model. Like we try to cover everything in 1 sentence, right? Okay, send money, wrong account, resend it tomorrow. Okay, here is another game. I just want to let you know, okay, this one, like maybe it's hard for a model to make it correct, right? Okay, I'll stop here for another like 15 seconds. Okay. So the answer is, the first one is bar, the second one is gold, the third one is hours. So as you can see here, the big difference is, okay, rows have to work tonight for 2 hours. Our model is rows have to work for 3 hours. So actually it's 2 or 3. If you see here, it's about 2 hours in the beginning, but why? If you look at the context, it rows in the end say, okay, just be safe. Let's say it will take me 3 hours, right? So it changed from 2 hours to 3 hours. So which makes this bar model confused about, well, how many hours it's gonna get. So this one is factual error about the summary, right? But the gold model doesn't even bother like how many hours. Just say, okay, Diana is unhappy with Rose prioritizing work overtime with her. So this is a more high level understanding from the overall conversation, but two of this model cannot capture. One last slides, I think so. No, okay, no, two more slides. Here, I just want to show some error analysis about summary. So for example, like for current evaluation metrics, it's hard to say this is how to evaluate, for example, her or Lily or her dad or Anne's dad, right? And this one should be the same, like both are correct, but when you look at this roof evaluation, you won't get this who's dad, right? Or this some cause and effect discussion. For example, the reference summary is, okay, Paul will buy red rose following Cindy's advice. Okay, basically you can think, okay, Cindy have something and ask Paul to buy red rose. But our summary becomes Paul wants to buy red rose, right? Which is not true, because Paul doesn't, in the beginning, he may not want to buy red rose. And in the dialogue, if you check, he want to buy yellow rose, but Cindy want him to buy red rose. So this summary, although covers some red rose, but it's the pronoun is wrong, or the intuition is wrong, right? And here, just some other important information is wrong. For example, here, like the gold answer is Hannah needs Betty's number, right? But Amanda doesn't have it. But our summary become Amanda can find Betty's number. Amanda suggests to text him. But the important part is Hannah needs this number. So that's why everyone is finding this number. So yeah, this one just a kind of error, like what kind of prediction or what kind of factual error we will make. Okay, last slides, we will close this talk. So the same, like code and data is released and is uploaded to Hugging Face, the same model. So if you want to play with this inbuilt Hugging Face pipeline, you can just call this similar like example here, pipeline summarization, use my model, and you can just play with this summarizer for any kind of conversations. So feel free to play with it and send me any feedback, or you found any bugs, just let me know. All right, I think that's all my talk today. I'm happy to take any questions, and feel free to follow me, follow Salesforce Research, and if you have any, if you're curious about what Salesforce are doing, are willing, or you're interested in joining our group, just let me know.
So first, please join me and thank Jason for this very nice talk. Yeah.
Thank you.